Hello and welcome back to Video Game Coding in Leaf. Let me give you a general overview of the show first, and then we'll try to get right into it. Let's open up the game, and then I'll tell you what we're doing with it. Don't be shocked. The game's rather simple right now. The idea behind this game is that we're doing this in a language called Leaf. Leaf is a language that I'm writing. It's a new programming language. And so whatever you see in this game, you really have to understand that this is so far from the ground up, because it's the compiler has to be written, the connections to the libraries have to be written. We don't have any pipeline for graphics, for sound, for controls, anything like that. We're using SDL for some of the stuff. We're using OpenGL for the other stuff. But if you use those libraries, you have to understand those are really low level compared to what you need to get a game running. So everything we do, we're going to have to go through the setup of it. And let me just start this while I talk, because I can sometimes play while I talk. So every little bit here, although it's really not much, there's a lot of little bits and tiny tidbits about this whole thing. We're going to go through the algorithms. We're eventually going to create the computer AI. We've already created that on the Evening Rush show, so it shouldn't be too hard, except for the fact we have a different language, and I died there. We added these menus last time. And again, if you've done any type of high-level programming, menus are not like one of these things you jump on and go, yeah, yay, menus, it's really awesome. But, you know, this stuff, when you have no framework, when your compiler's missing stuff, when you have no standard library, it gets pretty challenging, and I actually chose the wrong one. So if you notice how I ran Leaf there, I'm using the project file, and this is compiling. This is not a dynamic. Oh, sorry, this is not an interpreted language. This is using LLVM's JIT mode. So we're not producing an executable, but it is compiling it in memory. There is a bit of a speed issue right now with LLVM, and I've tried to fix that. I'm talking to guys in the mailing list, but I have to come up with more examples now because it doesn't look like it should be happening. When you compile to an actual exe, it doesn't take as long, which is a little bit weird, except then the linker takes a very long time, but linkers are known to just be slow. At least the GCC one, we might do LLD afterwards. And so a bit about the game. This is the classic sort of Snakes game. I first wrote this one way too long ago. I'm not going to actually admit to how long ago that was. And the basic idea is that as you eat stuff, which gives you points, your little worm, or we're calling it a worm in this case, it gets longer. If you run into yourself, you die. If you run into a bush, you die. If that little cat or bear-like creature runs into you, you die. He actually has a defect right now that he won't actually walk into me. Even if he's about to walk right into me, the avoidance thing that makes them change directions, and I'll show you that right now. So if I go right here, he's going to change directions when he hits the bottom of me. That same little tidbit there actually makes him change directions when he's going to run into my head, which is actually wrong. We want him to run into my head. I should die when he runs into my head, so we'll have to put a little fix for that. But what I want to address today, the main thing I want to do is I want to do the small graphical effects that actually make the game, I don't want to say playable, but can start. Well, first off, these menu colors are wrong, so we have to improve the rendering here somehow, make them bigger or whatever. I'm going to return the menu. It's when I press start here. Alright, first of all, this shouldn't be moving yet. This is the big thing. This should actually be static, so we have an error here. Let me exit the whole game and come back from the start and show you what it's supposed to start like. If we start here, it's completely static. Now, the game starts and you press a key, but if you've ever played games before, that's like, yeah, what a stupid thing to say. If you've ever played games before, I mean, obviously you're watching Twitch. The chance of you not having playing games is extremely low, but if by chance there's somebody in the show who's never played a game before, please put your hand up, because, you know, that used to be interesting. Okay, but the idea, what I want to say is that no game actually starts in this static state. That's like almost stupid, because as a user of the game, you're like, what should I be doing? People understand the arrow keys. We're going to add controller support. But what I want to do today is that I want to make the game start immediately. But the big issue with starting immediately is because you don't know where you start. We have to give you some indication of where you start. even if we decide, and this makes a lot of sense, that you always start in the middle, and this makes a lot of sense, you should always start in the middle, because it's really a shock to the user to start somewhere else every single time in such a game. But even if you start in the middle, we still have to give some clear indication of, hey, look at you, your worm's right here. And so what I think I'm going to do is, a lot of the classic arcade games used to take this approach of either having some circles isolating on you, or you having you zoom into the place, or just making some animation that draws your attention to that point of the screen. And so that's what we're going to do today. At least we're going to get done more than that, hopefully. We're going to fix some bugs and do that and see how that works, and maybe change the gameplay a bit. The idea for gameplay is, well, okay, there's another bug. You shouldn't be able to die just by pressing backwards onto yourself. I mean, technically sure, but that's just really a stupid thing to do, and we should probably block it out. And so we'll do that and things. The other ideas for the gameplay is that make a bush appear every time you eat a fruit. Make it randomly appear. And we're going to see then right away that if we do that, and we'll get back to that later, we're actually going to have to implement an actual algorithmic thing that makes sure the bushes don't close off a part of the screen. And this is going to be a flood filling type algorithm that says when we place a bush, make sure the bush doesn't fill off the screen, and then we place bushes every time you eat something. So the game gets progressively harder. It's not like you can keep playing forever, and then it also puts a maximum score on the game relatively quickly. Alright, so let's get started with the visualization of starting the game. If you have any questions, then please ask about Leaf, about the game, about graphics programming. I'm thinking about starting a different stream from rudimentary graphics programming. If you're interested in that, just let me know. Feedback would help me, push me in that direction. And because right now we're doing probably already too deep. If you want to do new graphics programming with OpenGL, we're already probably too deep into it. I'll try and keep it up what we're doing. But we can start over on that again, and the other show would eventually build up probably over many episodes towards going towards Vulkan programming in the end, and why that's different, and we'll see as we get there. So, what was the first thing? Okay, the first thing I wanted to fix was a little minor thing, and this is in game, or not game, in main. Main is where our driver is. Main.leaf is, it has a generic center sort of screen, or center sort of loop. It takes an event, and if it's a key down event, it dispatches it. And what I look at now is that I realized while playing the game, we made spacebar activate menu items, but it's more natural for enter to do it. We'll make both of them do it, because if your hands are on the right side of the keyboard pressing enter, I know, crazy people, who the hell is using actual arrow keys? Why aren't we using the WASD keys? And we can probably add those now as too. Let's do the WASD keys as well. And we might consider two-player layer, but not for today. So let's add a few keys first so we get used to the structure of the code. We have a main, we loop through, and as events happen, we dispatch them. And we have different dispatching modes. And this mode's a little bit clumsy right now because Leaf is missing the concept of an interface or a trait. And so we kind of have to do this weird dispatch-like thing. And here we select a function and then call it. So functions are high-level objects, and you can select a function and then apply one call. So it's not actually terrible, but it's not what you'd expect to see in a high-level language. I mean, it still works. So stage menu, we're in a menu, and we have this weird thing now, and this is what I've seen about the problem not having an interface. I can't really merge these two functions. They handle the same keys, up, down, and space, up, down, and space. But because I don't actually have interfaces, I'm calling a different object here, render menu up, and there's no way to unify that yet. So this is what we're stuck with. We're going to have a bit of duplication here, and I'll put a to-do for that. Can't remove the duplication until we have interface/trait support. Once we have that, we'll remove the duplication here. And that's for me to do in the Leaf language. I'm not going to do most of the Leaf development on... I guess we don't need this. We don't need... sorry, I won't do a lot of Leaf development online because that's actually really deep coder stuff, compiler stuff, and most of it's really just me there sitting like this, wondering, have I made the right life choices? Why am I debugging this now? Could I be doing something else? I'll do that all offline, so we don't have a depressing show. And let's add one here. Let's add an OR condition here, an OR keyevent.keysim .sim equals edA-qa enter. And we're going to duplicate this. And what I mean about having nothing available to you is that normally I think this is edA-qa enter is the correct key. And edA-qa enter, this is probably the enter key. Key code. And we do have an enter here. We have an enter. No, keypad enter. Oh, wonderful. No, I want main menu enter. Oops. It's return. Okay, what do you call it? Return then. Main keyboard return. So it's return. We don't have these variables defined yet. This is part of using C, you would import the library. There's a lot of libraries that will actually import C libraries for us. I'm not quite so far in Leaf. I don't want to import all of SDL quite yet. I don't want to throw this massive challenge at my compiler, especially since it's unoptimized quite yet. So we're going to do it a bit by bit, and we have to make this ourselves. So if we open up the lib, and we go into SDL key, wherever this is, SDL event, you notice I've defined keys right here. And we're going to have to define the other one. And I think this is now correct. This 2D resolved itself. It wasn't working before. And so now we have to do literal edA-qa enter or return. We have to go figure out what its value is. We do have header files, but a lot of these things actually it's not helpful to look in a header file because they have a weird formulation. They have like an OR bits and some flags and stuff like this. So what I did is I did a Cpp Test Function. So we're going to actually run SDL code in its native form, and we're just going to output the keys we want, edA-qa return. At the same time, we want to enter the other SKW, I guess. We want to look for the other ways to control a character on the screen that the real gamer types tend to prefer. I'm not one of those types, don't worry. Alright, probably shouldn't say that. If I had more time, I definitely would be one of those types. Oh yeah, and to put people at ease, I'm going to change the order of this because I know it must pain some people to see WASD in a different order. That would definitely not, and this is probably the same thing up here, up, down, right, left. You probably use it up, left, right, down. Now I'm going to leave it though, you have to suffer with that one. So we have WASD, we have that one, and we're going to run this program first of all, and -o/temp/ whatever, didn't have a name, and what is the name of this directory? CPP. What? This is a bit weird. Why is my tab not working? This is just really funny. Cpp test / I must have the command line somehow wrong. Alright, so edA-qa is not defined. Yeah, the lowercase. This is really... That's a bit weird, to be honest. Am I supposed to be using the key code or the scan code? Let me check what we're actually using. Main is... We're using the key code symbol. So it's a little bit weird that we use lowercase here, because this is like the character symbol, and there is no W symbol, I think. We're going to find out right away. Alright, so now we run temp demo and get the values out that we need. And these are on hex, so don't be surprised. We just have a D for edA-qa return. A lot of them use the ASCII codes, it appears. Most of them don't. This must just have been a historical thing to use the ASCII codes for this stuff. And in Leaf, we just put them in hex mode. We'll just stick them in that way. And I don't know why I didn't make this thing just output the full syntax. We probably should have. But we do it this way for now. So here's a big question when we do this. Do I leave the convention SDL had, or do I uppercase this for our convention? So far, I've just been taking SDL's convention, and I think that's the way to go, just so we're familiar with what's happening here. Because, I mean, uppercase stuff is definitely not a Leaf convention in any case. Same, I mean, this type deaths up here, we're using theirs, but the function names, we're definitely using the Leaf style, all underscores and lowercase there. So let's go back to the main one. We have key return, and we can do the same thing up here. We can do the same thing with key event.keySim edA-qa w. Now you may be wondering reasonably, why don't I have like an or, an in, or some sort of thing, combine these together? And it's like, yeah, that's a great idea, and definitely it will come up in the language. We will create something like probably like Rust's matching system. They use match, and I might use select, but I'm actually not sure what term is match. Tends to be a happier term. I think a more correct semantic term. So eventually, I think we'd assume to see something like this, where you'd have Cpp up or edA-qa w. And I don't know about this part. This part is more Rust-like syntax, but we would definitely have something like that, and might probably be a colon here, or actually just an equals in Leaf. And then you do something in here. This will be the syntax I'd go for eventually, but I don't have it yet. It's not very high on my list. Traits are much higher on my list. So for now, we're stuck with this ugliness. Just pretend we're doing C coding from a long time ago. C, you know, just pretend that. But we'll get towards this as we go on. As the compiler goes on, we'll keep adding this type of stuff. Part of the reason I'm doing this now, even without a full compiler, is because if you try to keep writing a compiler without any use cases, you end up with crap. I mean, it's all APIs. I'm sure you've all used them. You downloaded some API, and within like 5 minutes you realize, oh, I don't think this guy's ever actually programmed an app with his API. What was he thinking? This is like totally wrong. So for Leaf, we're going to do the same thing. I got to follow the same philosophy. This has to be capable of doing something useful, otherwise it's pointless. Alright, so let's run this now. We've added those things. Now I should be able to press enter as well, and enter works. Now, I'm not as good with... The other keys also work. You can't tell, but I'm now using WASD. And I'm actually really bad with these keys. I do not play games on a PC. I tend to use just my PlayStation. And you may look down upon me now if you want, or up at me, however you'd like to do it. My preference is for good games, and I don't care what platform they're on, except I just don't play on PC. I have a Linux system anyway, so I don't even have Windows. I have no Windows machine anywhere, and that makes it hard to play a lot of the PC stuff. But I do have a Steam account, and I do I do download stuff regularly. Alright, now edA-qa is referring to the Evening Rush show, and we're looking for stuff to do there too. Evening Rust is a show where I do Rust and I use Coding Game and we solve programming challenges. Now I have two suggestions. I have Clash, oh no, I have a Smash the Code, and now I have a Korean. Well, edA-qa is a stream name. That's the interesting thing about Twitch is I don't really know how to change the stream name per episode. I'm kind of left with sort of one title for the stream, so if I do multiple things, I don't really know what to name the stream, and it's kind of an issue. It's, what should I name it? I don't want to go in and change the name every time. It's a bit of a headache. I really wish something like OBS, like we use OBS, if OBS had a little plugin that just said, okay, now set the stream name to this, that would be perfect, because then I would actually change the stream name dynamically. But for now, you're going to have to live with Evening Rust, Leaf Games, and algorithms, and you just have to deal with that. I mean, for all things in the show, I'm hoping the title is not the most complex thing. So the WSD keys don't work on the menus, and I'm going to leave it like that. Only the arrow keys, and let's just return to menu and quit. So the next thing is we want to make the phase in, the actual graphical bit. I'm going to ignore this bit for now. We can fix that later. I want the phase in bit. We're going to commit this now. Git status. Git commit. More keystroke support. And this code is all online. I'm going to show you where it is. Even if it's going to sound really weird, SDL. So, and this is in the Leaf and SDL code, and I should have to update that as well. I'll put this over here though. Let's update that file right now. So if you intend on compiling Leaf, the issue here is compiling Leaf. It's not the code's really easy once you have it running. And in SDL we have a README. And I created last time, because I hated typing the library all the time, I added a little project file system. So now we can do wormies.leafproject.yaml. The purpose of the YAML is to clearly indicate that this is kind of a temporary format. Leaf project will eventually have its own format, but we're just going to use YAML for now as a suitable format. I'm not supporting all of YAML, but it's using standard format. And that'll be in the documentation. So when you run it, you just go, where did I put it? And this is the full path to the distribution. If you want to check out Leaf and build it, you build it, you do scons dist. So it's like scons dist, and I really have to update the docs for this, scons dist. And then you have this directory, and then you just run the project file. You can also run any individual Leaf file. There's several formats for them. And if you are tempted to try it, just let me know and I'll update the docs. I'm really bad with getting the onboarding, and it's going to be a hard project to use still. Don't get all excited that it's easy to use. But there's the code for everything. And now I want to do the start. Like I said, the start, we want this to zoom in, and I'm really wondering how I do that. I think, and when I say how I do it, I mean, where does this logically belong in the game? So in the main loop, we call a step with an elapsed time. And it's step, 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 step. And the game is responsible for logical time. We changed that before. When we first started the time looping, it was the main loop responsible for that, but that didn't give us enough control. So now what we're going to do is we're going to make the main thing, the game itself, the game state, which we called game. No, we called it app game. Very careful. So we have a wrapping state as well. The app is the high level one, and this switches between the screens of menus, playing game, and end screen. And it has a step function, and it calls game state step. And it doesn't much care for that, and it really should be I'm not let's go into game state first. Let's ignore that top little bit. It always calls steps here, so we have a step function here. And you notice in Leaf that functions are all high level, that technically they're all lambda functions. They don't have any names. Functions have no names whatsoever, except you can assign them to a variable with a name. And for debug support, when you have this support here, this function will get the name step or something similar to it. Otherwise, debugging would be impossible. So now we have, somewhere in here is a pause function. I'm positive. Pause. Where is pause? That's my key thing. Where is pause? Running here is run equals false. Run, 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 run. Run. Not earn, run. So I'm looking for what actually delays the start in the initial round. We had it, and I've forgotten what it is. Move, we do a step. Where's a step? Wow, let me check that. I think it's mainly back maybe in main. Oh, right. Pause is up here. Now, pause is a high-level thing, and that's what's pausing it. And that's what's actually wrong. Pause is just sort of that key that pauses it, everything. And that should pause the complete state. So the state shouldn't worry about that. The state doesn't need to know about a pause because it's just not going to get time anymore. And so it's correct to deal with pause here, but the game should start immediately. We're going to leave it in the pause state until we fix the next step first. So in the main thing here, we're going to do back in game. And we're going to have a warm-up phase. Warm-up. And this is a float. And we have to have a start here somewhere. A start game, start. Or actually, I think we create new ones of these each time. Let's put it in the constructor, which actually means it's in the constructor. We just do this. The warm-up time, let's give it 2 milliseconds, or 2 seconds, okay? And we do step quantize, step check, step elapse, minus frame step. And we're going to skip this part here. We're going to skip this part here. We're going to say if warm-up is greater than 0, warm-up is greater than 0, then return for now. And this sounds really silly, but it's definitely going to do something because we're going to put another indicator to the renderer. So we can see that work right away first. 140. I always forget to do that. I don't know why. So now when I start the game and I unpause it, nothing happens. And, well, okay. I should probably, you know, reduce the warm-up time. Minus equals elapsed. So now I press a key, nothing happens, and then 2 seconds later it starts. What I want to do is in that 2 seconds, I want to make the animation of the creature coming into the screen so that it zooms in and everything else can zoom in. And I'm trying to figure out how to do that. And maybe I'll have just a special flag, because warm-up may or may not be a special flag, but maybe we can just put it on the little creatures on their own. And instead of putting warm-up here, we have something called game dot. And these are for all the dots in the screen. Let's give them a warm-up as well. Let's give them a warm-up instead, so we can make it per little thing. So every time something comes on the screen, we can do the same thing. And where do we actually do this? We do add... I see, set next eat me is a place where we call it next dot. And next dots, we're going to do dot.warmup. And by default, we're going to make everything warm up for 2 seconds. I know this might be excessively long for a game, but I want to be able to see it in the stream. I want to see how it happens. Except the bushes. Bushes should not have a warm-up. Right, because bushes don't need to zoom in or anything like that. That'd be really kind of silly. And as much as I just thought this was a great idea, now it's a really dumb idea to do this. We're going to leave this because our worm does not have a warm-up, does not have a dot. So I just completely screwed that up. So let's do this here, body, and let's go back to where we said warm-up. We'll leave the warm-up and those other things because we're going to actually stick that in there as well. And for down here, step elapsed, frame is stepped, we're going to do... We can still do step quantized. We can still do step check. Yeah, okay, this is going to be a bit of an issue here that we can't combine these things. So the main warm-up's going to have to be completely this way as is. Alright, that should be enough. Warm up, and we'll do that. And let's go to the game renderer. Now let's check where we're rendering the state. Oh wait, I split this up last time, the game field renderer. And let's see we're doing that. We have... Where do we render this? Where we render the body segment, render body. Render foreground, background. Push body segment. I think it's going to be here. And this partial bit right now makes him small. Could we do something that makes him big? Do we have to do a different rendering of him? Or do we just do like a special rendering on top of it? And that sounds like the best idea. Let's render the body wherever it is, but render something special on top of it. So we're going to do state.warmup greater than 0. We're going to draw something else here. And I don't know what to draw here. Can we abuse push body segment and make something really big? Push body segment. I think that might be a bit weird, but it'd be the most round thing. It'd be the easiest thing to do. Let's just see what happens if we make a partial value less than 0. Wow, that might screw things up, but it might work. It's a cheap solution, I don't want to get doing too much stuff, so let's do that. Push body segment. And there's a head position here somewhere. Game has a head position, right? An eye point. And body segment requires, however, this is where it's weird, body segment requires point, a color, and a previous and next. Oh, that's okay then. Head position. And let's just do it with the same body color. And we're actually going to pass the same points for the previous and head position. So we use the exact same positions if we know it's not moving. Head position and head position. And the partial thing was we're going to do something really weird. We're going to cheat, and we're going to say, we don't have to, we'd say minus state.warmup. And this is going to make it, you know what, I don't know. I think it's actually state.warmup is the time. Possibly +1, and let's just see what happens here. Let's just go with this, okay? And 240, I have a syntax error. I really forget then a lot, and it's necessary because there's actually no way, because function blocks are high-level functions as well, you need this then to make sure this is an if statement. Otherwise, it's ambiguous. I mean, it can't mean anything else right now, but still. Bush.warmup. We'll make those things in order too. Head position. Whoops, what did I do there? Just not body.head, but head position. I'm calling the wrong thing. Alright, so the idea here was that... Oh no, we've clipped it in size! No, that's a problem. We forgot about the clipping. So watch what happens. I'm going to start it, and it shrinks, but the actual body segment is clipped in size, so we have several options here. Logically, this is not a body segment. We have an identifier, or it's a bigger body segment, or we provide us things called scale to body segments. And let's just do that. Push. Let's provide something called a scale. This is the simplest way. Now, they all have a scale, but I don't want to start repeating code too much. And the scale is 1 by default. And the scale on state.warmup is... So the partial is 0. It's not partially drawn. It's fully drawn. That's important here. And state warmup +1 as the scale. And 2 seconds are going to start bigger. Let's make it even start bigger than that. So let's do 2 times state warmup. And we'll push the body segment. Yeah, we need a scale. Where does scale apply here? Not to the base. The base stays the same, because we want the base to be regardless of what the scale is. And what we have here is relative x here, times partial, and after this clamping comes into play, then we're going to do times scale. So we clamp it to the normal body segment, which creates its distinctive shape, and then we do the scaling on it. And that's the only part that affects the size of the triangles we're pushing to GL. And there's a good chance it didn't work because it's not showing up right now. No. So we did something wrong. You know, maybe this clamping has to take care here. I just don't know anymore. Clamping. No, it should be fine. What we're doing here is we're creating little segments in the circle. And I think we had to deal with that. We have the segments of the circle, and I have to trying to think, the scale should have done it because that extends it beyond the clamping region. We have the angle for each increment. Then we take its offset, the relative x. We times it by scale. and text coordinates. Now I've forgotten why I do this weird calculation. Velocity 0.9, 10%. Oh yeah. Because we created this weird shape. It's not really a circle, and it's this bit. This creates a circle, and this like basically says, well, it's not really a circle. Let's just take little bits of it. Although honestly, I can't understand this at all anymore. It's a bad place. I've forgotten really why the hell do I do this. Oh, this is the text coordinate. No, the text coordinate was fine. So why do we? It's the vertex coordinate. Vertex data plus x plus relative x times scale should work. Let's make the scale a lot bigger so we can see it. Let's do 2 times plus 10 for state 1. That just is something really funny here. Like, it should appear right there, and it doesn't, so we've done something wrong. Let me check here. Let me just make sure we have something standard. Whoops, standard.println. Warmup. Don't worry about these square brackets. This is just leaf because we don't have variable arguments, but you can pass a tuple to these functions instead. It is printing warmup, which is a good sign. It's printing warmup, it's just not really getting there. And we can print out what the warmup is then as well. State.warmup. Just in case we're debugging what's happening, we can figure out what's actually happening. Warmup 2. So that's fine, we're in a static state. But when I start the game, you can see it counting down. The question is, why is it not drawing anything? And oh, maybe partial has to be 1, not 0. I might be drawing partial 0 might mean it's not there. Oh yeah, we're gonna have to change the texture size as well. I forgot about that. So now it is working, but we're drawing the entire sprite atlas, right? So we've gone outside the texture bounds, and this is our entire atlas. And we have to fix that then as well. Right, give me 1 second. I just gotta go check on something. There's a teenage girl's birthday party here today, so I just gotta make sure they're taken care of. I have to come back. Give me like 2 minutes, and I'll be right back. Thank you. Alright, so you don't hear screaming in the background yet, so that probably means that the teenage girls' party has not started yet. When you hear the screaming and the loud voices, then you'll know it's there, and I might have to take another break, or I might just keep myself locked in this room and away from all of that. And so now, we have to fix, what do we say? We screwed it up. We have 2 times state plus warmup plus 1 scale, 2 times... Let's do 2 times. Let's keep it nice and big. And I screwed up the texture coordinates. Now, why is that? I think it was called rel x. Where are we? It's because relative x is used for the texture coordinates now. So we applied the scale to rel x when really we need to apply it down here, because then we've applied it only to the vertex coordinates and not to the texture coordinates. So now we might have this zooming in. Alright, you can see it right there now, nice and big. Now the fact that we show this in the start screen, that sucks. That's a whole other issue though. I mean, the bushes are on top of it too, which is also another issue. But maybe not so bad. Because if you're starting this game, knowing where the bush is could be immensely helpful to you, rather than starting in the middle of nowhere. And what did I press? I pressed the wrong one. Again, we talked about this last time. When you have a menu with 2 items in it, you have no idea which one's highlighted. And there's actually games out there, and I found them on Steam before, and there are like PS3 games and 4 games like this as well. You have 2 menu items, and if you don't highlight them correctly, you can't tell what one it is. And I think we chose cyan. No, I got it wrong. No, let's go. It starts and starts. So now we have this big thing here, and when I click to start, it goes, and now we can see where we come in. And perfect, we actually come in, and that's what we want. Now it's a tad bit slow, it's a tad bit ugly, but that's totally okay. Let's work on that. We've got that going there. And we're going to quit that, and... Oh wait, just let's see it once more, just so you see where it is. I think it has to be bigger, to be honest. Start. I think it has to be bigger, although that's pretty damn obvious. And it has to be flashier. And by flashier, I mean not that. Let's cue that up. So what we should do, though, is that the game here, you saw the game has 2 seconds, right? The warm-up. No, we need game. Yeah, warm-up. Where's warm-up? Warm-up. We say 2. Now, if you're doing the rendering, you don't want to be dependent on this value of 2, because you don't want to say, well, 2 times that, that's bad. What we'd like to have is normalized value. How long are we in this warm-up phase, and let the rendering decide for ourselves. So the warm-up here is, wherever we did warm-up is 2. 2. We're going to create another one. We're going to do another literal warm-up max equals 2. I want to say this is the warm-up for the worm max. Warm-up max is 2. And we're going to create a helper function for this. We want to say get warm-up relative. And this will be the relative warm-up time. And this is simply a matter of return warm-up divided by warm-up max. And it's not allowed to go negative. And we're going to hide this because I don't have... We'll just make this warm-up here as underscore. Because I don't have private stuff like this yet. I don't have marking score. We're just going to put underscores in the stuff that you shouldn't be using. And let's find the rest of that warm-up here. And so the underscored stuff is basically private to the class. And we're going to... That'll be enforced in the compiler at some point. Right, so we have this warm-up initialization. We have get warm-up rel, and we can use that in the game, in the field renderer now, wherever we use warm-up. Now, whenever when you have temporary variables, you should just say something like this: warm-up equals state.get warm-up rel. It's a function, and later Leaf will actually have proper accessors. And this is something coming from the C# world because they have accessors. They've promoted this very standard pattern of when you use something in a class, you should assign it to a temporary because you don't know how costly it is in the accessor. Of course, I tend to have the belief that if you have an accessor, it should be really fast and you should never have to worry about that. For now, we're going to do it this way though. It is a common way, and I'm not entirely sure I agree with it, but I also want to make this a tad bit bigger. Let's do 2.5 times the warm-up. And this is just a scale, so we can't actually do that much more with it, except we have these things called color. And I would like to make it start somewhat translucent. I think that would be somewhat helpful. So when we go to push body segments, we're going to have to add a transparency to all of them, right? GL float 3 is something, when we push this thing on color, vertex color push. Oh, Ray, we don't have... Yeah, we don't have opacity here. In a 2D graphic system, you can certainly add opacity. You have to worry about drawing order. And we have a 2D drawing system, so we can worry about order. In a 3D system, you can't worry about order. So let's come back to color in a sec, because this requires quite a few changes to the code to get opacity on this. And let's make an easing to this first. And so what it said is that we have... You don't want to just linearly go. That's just no fun if something's linear. And I did a lot of work with this at Fuse. I was doing all the easing type stuff. I did all the animation. And I had simple access to animation functions. But we can simply create one now, how we do the easing. Because the warm-up is now relative between 0 and 1, we can apply a very simple formula to this. We can do... What do we want to do? I really want to do like a... Probably like a cubic out. A cubic out basically, and cubic out then basically means I think I have a math function. We can do math.power and warm up. And we want it to go really fast at the end. So I think that means we square it. I don't remember. Let's just do a square for now. So it'll really fast at first, the curve, and it'll slow down. And that's more of a cubic out type thing. Now let's see if we actually get that cubic out one. Warm up max. That's fine. I screwed that up. Warm up max is because warm up max. Right there. I forgot to do it. Now when I start, I'm going to have to press the button. We'll see what happens. So that is definitely, that was kind of a cubic thing. I'm going to put it up to cube though so we can see it better. And we're going to get rid of the pausing now. So the game immediately starts. That's what we couldn't do before. In the main code, we have the game starts as pause. Pause equals true. We're going to make it start with false. And we just get rid of this unpausing. Oh, there's something about last ticks there that makes me feel a little bit uneasy. That should be fine. Again, if you have any questions or you want to know anything about Leaf, the language, what we're doing, please ask. I'll give a view again, like in 15 minutes. If there's new viewers, I can tell you a little bit about the whole project again. And unpause, we don't... Oh, we should have kept unpause because something uses it and just removed it from here. Alright, you can see it worked there in the title screen, and then it blinks like stupid. I think I remember why we had pause, but on the title screen it's not so bad to have stuff moving. Not really great. So now when we start, it goes like this, and the game immediately starts, and he's blinking because I'm not moving, because you always blink while moving. So now here's the question. On such a game, which direction do you move first of all? Should I have a default direction? Doesn't make sense. Or what should I do? Should the worm always move? Or should I still wait for the first keystroke before we start moving? And right, because right now, he's still flashing because we have no direction. And I just don't know if maybe it should have an initial direction, or what should you do? What we can do, and we'll have to see if this works, is let's set an initial direction, and if the user presses something during the warm-up time, that direction will be used instead. And that gives the user a decent chance to change the direction if they want. But we're going to clear any other key they typed while doing that warm-up. Alright, so we're going to go off to game again. We have somewhere called moving. We have something called direction. Okay. Where do we set direction the first time? This is not the direction. This is the other direction. Now we used to have this where they're not moving, and I'm going to leave this check in because we might actually have a situation where we want to pause them later in the game, but we're not going to start that way anymore. I'm going to go right to the top. I want to set the direction as equal to, I don't know, let's just point him to the right. That's a good way to go for a game. They're just going to the right for no apparent reason. And now when we do a move like this, not a move, but what is move called? Move. We need to request move. We're going to say if we're in the warm-up phase. So if warm-up is greater than 0, then, I'm going to do an else here, then direction equals x off, y off. So the initial moves up until the game actually starts just determine the initial direction. Let's see if that actually works. We're going to take the first one, and it's just going to go up. So we go like this, and it goes, oh, to the right, I mean. And it starts going to the right, and so that feels reasonable. Alright, so now I'm going to go back to the main menu, I'm going to start again, and I'm going to press up this time. So I press up once, and it's correctly interpreted that that's going up for the first time. So we have that initial control in place, so that's pretty good. We have the initial animation. It's not the best. I wanted to make the time quicker, so like, right, start, it's still pretty slow. I prefer to have it bigger and flash in, right? Come on, I mean, we might have to reduce the time on it, but I don't. 2 seconds isn't horrible the way it's, and this is a big thing with game design. You have to really worry about all these forced times on the users because when you do something lots and lots, it's really annoying. Most games probably have a loading issue more than forced time, but sometimes you have these forced things. It's just like forced cut screens. Whoever still believes there's cut screens you should have to watch is an idiot and should be kicked out of game design. I have no idea why people still do that type of thing. And in the same way, this is why I'm really leery. I mean, this is just a toy game for us. It's not like it's something in a release. I'm really leery of having any sort of fixed times in the game where you can't skip over it. If it's fast enough, it's not an issue, but you should be leery about this if you're actually doing a significant game. So now here I want to make this go bigger. Let's make it much bigger, and we're going to make it scale out really fast now, though. And you'll see it right when we start up, too. So that looks a bit better there. We actually have the same amount of time, but you see an issue there. Right, you see how long that sort of pause is there? It's not a good easing for what we want. The initial thing is great, but then there's that little nagging sort of yuck. Why is it actually... Why is it taking so long? Right, because the moment it gets to the size you want, it should immediately start playing the game, but it doesn't. So if you didn't catch it again, let's do that one more time. You start, look at this, and it doesn't start. You have that delay, and that's bad. That delay is really bad. And it's probably because of this +1, and this is because this value gets too small. So we're going to have an easing that goes back to something normal after that point. And we could check these online. There's a site I've used a lot for these things, easings.net or something, that has the CSS easings, and it gives you a good curve of what you want. And this is about what we have right now. We had cubic, and by putting up a cube, it becomes quartic. And you notice that the first part is what we want. It goes in really fast, but what we really need is we need it to come in fast, and then actually not have this final little bit here. This is bad. This is bad, and I'm trying to find one that makes sense, and none of these might actually apply. Like these have this slow curve at the end is the problem, because it confuses the user as to whether they can actually start moving or not yet. And so you want more of a linear curve there. I don't know if there's one that's applicable. We might have to combine something here. You can clip these things out. So you can clip this, like, just say near the end it goes away. And how do we do that? Well, something like bounce might honestly be okay. Or elastic. Out elastic. That's it. But bounce makes sense. It's going to pulse a bit and then go thunk and get the player in place. And because it has that nice curve at the end. But do we have the equation for this? No, it's not going to give us the equation for it. Come on, give us the equation for it. I don't know what the equation might be. So we're going to do something else instead here. We're going to make it half linear. We're going to make it linear near the end, and so we'll do this. I'm wondering how we do this, because we don't know how long it's actually going to take to get there. Give it half the time for the big slowdown, and then the rest is linear, or a quarter of the time. But we have to make it big enough. Wow, little animations really suck. How do we? Because we don't. It's not quite fixed at the time. There's no let. I'm using the wrong term. I'm using so much Rust. So simple things. How do we want to do this? And I typed something quickly on my phone here that beeped. And right, it's really kind of a weird curve I want. What we can do is plus warm-up. This is definitely an option. You can do plus warm-up, and this guarantees that it continues to shrink in size. Now it's going to start bigger, so we can probably do 3. And sorry, I kind of have to get this call. Sorry about that. Just a second. Nice and fast calls. That's what they should be. So this should actually make the easing a little bit better. Let's just check that out. Let's see what easing we have. I just get rid of this var here. And you notice what happens is that I keep pressing the wrong damn menu item. It slows down at the end, but when it actually reaches the final size, that's the important bit. It actually goes, right? When it hits that final size, it actually goes. It's not like a visual thing that you have to wait, like, why is it not going? So we do this again. You can see it goes and slows down to give you a chance. Now, what we might have now is realistically 2 seconds is probably too long. Because that's well, I mean, so raise your hand if you think 2 seconds is too long. I'm going to reduce it to 1.5 and see what happens with that. We put equals 2 here somewhere. Let's do 1.5. Now, if you're wondering about leaf, what the hell does literal do? Literal is like a constant. But there's something very special about numbers in leaf that I don't know of any other language that really does this native number set. When you say literal worm max equals 1.5, this is getting a rational value, 3/2. This does not assign it to an integer. This does not assign it to a float. This is an actual exact value of 1.5. So if you type like 1.13, even though knowing binary can't represent this, this is currently in this value exact. There's no precision loss here whatsoever. It's an exact value. It's only when it finally converts it to a float like down here where it actually does the precision change on it. And I do this to avoid a lot of situations where you're seeing things where you have stuff like 1 divided by 2. And I've written an article about this, and I'm going to go to it right now, is that this is actually one of these peeves I have about a lot of things. Mort-ora-y, let's say 0. Let's call it 0. It's pretty bad in terms of typing when you type 1 divided by 2 and that's equal to 0 in a language. Now I wrote this a while ago, so I don't remember rendering it even. It's even using the old syntax. The idea basically is that saying 1 divided by 2 in these two situations, let's say in C, in the first one a person could reasonably assume, hey, you know what? An integer can't hold that value, so you get 0. Well, what doesn't make any sense whatsoever is in the second case, if you're assigning a float 1 divided by 2, anybody who reads this logically, anybody from math background, even if you're doing computing, you hit the same error all the time, you're expecting 0.5 here. You're not expecting 0, and this causes bugs in a lot of code. And I've seen this bug happen lots and lots and lots because people are dealing with floating points and they happen to have 2 integers stuck inside their code, 2 constants, that suddenly do something wrong. Now, even in the first case, I disagree with the fact that this doesn't produce an error. And in Leaf, this will produce an error because you can't assign 1/2 to an integer because it's not an integer value. And it's going to complain to you. It's going to say, no, hey, you can't do that. And 2 over 2, fine, because it's irrational and it can figure out what's an integer or not. So there's that article. Please do read it. And that's my opinion on some of those things that we have to. This is part of what I consider type safety. It kind of made me unhappy that Rust inherited that problem from C, that 1 over 2 in Rust is also 0. And it's a small thing, but it causes a lot of bugs. And part of what doing Leaf is I'm trying to get rid of some of the common bugs. So what time do we actually have here? We want it actually 1.5. And so what I'm saying here is you can put 3 divided by 2, and that's the exact same value in Leaf. This is literally exactly the same as typing 1.5, regardless of the context. In this Go fashion. Now, and I think that's fine. So we're going to start the game, and we're going to start going up. So now we have a reasonable start to the game. So that's one fix. We have that initial animation, and it gives us kind of the idea of how we do that. Now you notice the other guys too, like that apple and stuff. You notice when I eat it, come on, come back here, apple. Damn apple. Wow. The next one comes in and it zooms in as well. Right, and you can see that there. And I don't know what mechanism that has. I think it has an age mechanism. And I said we could replace that with Warmup. Because what's a little bit weird is that when you start the game, the apple zooms as it comes in. And it makes more sense to zoom the apple first before it starts moving, so we can create a similar type of warm-up for the apples, for the dots. We're going to scale the warm-up things as well, so the player can recognize them. Because watch when I eat these little cherries. You get no visual indication of where the next cherries are. You have to scan the whole board again, and that's not exactly very pleasant. And we want to draw the user's attention to them. So let's do that. Let's give them a warm-up as well. And the initial thing, the initial scaling that we did, we can probably ditch. We don't need that anymore. Let's check in stages. We're doing proper development. We're going to check multiple commits. Added warm-up to body. Now let's look at the field renderer. Where are we doing this in the field renderer? We want to do, where was it? Push dot, push dot, push dot. Push dot has its own function. And push box takes a partial amount, and then it pushes the rect. And it has a size. Now I'm going to get rid of that mechanism for the partial bits, I think. We have to leave, not for the size at least. No, it's the age. This age bit is the part that's broken. We want to get rid of the age thing. And we don't care about the age anymore. That's not what's going to be defining the partial. We're going to do the warm-up of it. And we can see what happens with that then. I'm trying to think. Yeah, I don't know if we really need age anymore then, because age was really addressing the same thing, but I think the concept of warm-up actually makes more sense. Age could be something else that tracks internally. And warm-up would mean, hey, you're not even moving yet. So during the warm-up, let's take this away. Let's just say ... and not pass partial anymore. And let's say size, or scale. I'm going to scale it. I'm going to scale it. Because the partial already applied otherwise, so we can make this scale. And so the size here is fine. So we're going to apply a scale. So the scale is going to be the exact same thing, 1 plus ... warmup. And again, we should have the same formula again. We should do the exact same thing. And one plus ... I don't know why I typed Q. Sorry. 1 plus ... warmup, and it scales it. And that'll give us at least a little bit, and it's not going to move in that time. But we have to fix the game now for warm-up when we have like a step dot. It's going to be, the dot's not going to move until it starts up. So we're going to say, now this returns a new dot. Previous position we can keep. This is fine. I'm going to say ... warmup is greater than 0. Oh, no, now I know what the problem is. Ouch. Our dot stepping is in quantized time, so I don't have an easy way to apply warm-up. I'd have to have a second loop that goes through them for the warm-ups. So that might not be so easy. Yuck. This is a bit hard now. What do I want to do with that? How can I do that warm-up there? It makes sense it's easier to do the main head position because it's just one of them. It's just one thing and it's very easy to add. And I don't want to put a second loop to the dots, but maybe we have to. Let's just do that then. Let's make a second loop. So if it's already instant warm-up, stepping a dot does nothing, and we'll create a second loop then. With a step quantized here. And we're going to have to do a second loops suck. I mean, but I don't really have an option here because we have the quantized stepping of the game because it's broken into segments, and we have the non-quantized section. So let's just do step warm-up. And this step warm-up here has to be separate because the rest of it doesn't happen, and these things still. Alright, so we're going to have to do this because we want. Alright, let's see what happens when we do it this way first. You're going to see I have something in my head that there's an error with this about the synchronization of things. And there's a for loop here for all the dots. Where did I put the dot? Step dot. And we just manually did each of these things, which really sucks. I've been meaning to convert that to an array. But for now, we're going to do it this way. That makes it worse. We have all these dots. And alright, let's convert this to an array first because this is going to be a bit weird. We can leave step warm-up doing that. It's empty. But we're going to put these entities into a vector somehow. Because right now we have 3 independent dots, And the bushes are a collection of game dots as well. And so instead we're going to give these things a type, I think we're going to give them a type. But this makes it also hard to deal with it. So this stuff is actually not hard to deal with. You had a standard library, but since I'm completely lacking a standard library, I have the vector, but we wrote that. It's hard to deal with. Where do you put this eat me, chase me, and monster? There could be multiple monsters, could be multiple eat me's, there could be multiple chase me's. This is really getting kind of silly, so let's just go with it. Let's just get rid of it. Let's have dots. Let's move all the dots first. And a dot is going to have a type. Oh, you can't have type, so I'm going to put what. If you watch my Reaving Rust streams, you'll get those often too. And what for now, unfortunately, an integer because I don't have enum types yet. Little GD bush equals 0. Literal GD. Let's just say cherry. Game doesn't have to know what that is. I had eat me and chase me before, so maybe these are static. They're like, let's just call this food 0. And call this one food 1. And then we also have monster, GD monster, and this is 3. So we have these different types. We're going to get rid of eat me, chase me, monster, and bushes. We have those 3 types. So we have to find all of them. So let's go through it. And this is going to be a bit of a challenge. I'm just going to read through all this code very carefully here. Set next, eat me, set next, chase me. This is totally fine, except when we do add bush. These are now dots dot add. And bush dot what equals game dot bush. It's going to be a bush. And so eat me dot what equals GD. And I'm just going to keep this name. This needs a name now. Var food. And I'm going to name it food. Proper refactoring here. Food dot direction. And what do we call it? Food 0. We're going to make this one food 0. So eat me becomes food 0. And chase me is going to become food 1. But now we have to add it to dot. Dots dot add food. Food is good. Var food equals next dot. Food dot what is a GD food 1. And this one has no direction, right? This is taking a default. This one doesn't move, and this one does move. So dots dot add food. Now the monster is the same thing. Var monster and monster dot what equals GD monster. So we're creating these types and dots dot add monster. Next dot random position dot direction. That's fine there. All right. So now I have to be very careful about stuff like eat me, eat me. We no longer have these stepping things here. We're going to step through all the dots. Now this unfortunately means we're going to step through the bushes as well. It adds a bit of overhead. And even though Leaf is inefficient, we're still hoping we have a magnitude of time more than we need to get this stuff done. So we have to be careful with how we do this stuff here. We kind of have to do an index-based loop because the step dot returns a copy of the new one. So index in standard range 0 dot dots dot get size? Oh crap, I don't even remember what I called that function. Naming's going to come later, just deal with it, okay? So dots index equals step dot dots index. This is kind of the functional approach here. Step dot creates a new copy of it. And our index operator in Leaf is the same as the subscript operator. Now the step check has to change quite a bit. The step check, instead of checking specific ones, is going to run through the entire set of dots and see if we've collided with any of them. And which is a bit of an issue when you have a different thing to check with. So let's just go through the dots again anyway. So for index and standard.range, 0 dots.get size. And this takes a copy of the dot. Be very careful about this. And we can use the for-index index for this later, but we'll use this for now. And I'm going to say dot.what equals GD food. So now you see it simplifies this because we only have one for GD food. Well, no, sorry, I was saying, but we have different scoring. And this is kind of tragic here that this is difficult to do, that we're going to remove something from the dot list. So we're going to have to do the range from the maximum to 0, I think. Let's go look up what range does. This is part of the Leaf standard library. It doesn't. That's really limited right now. Standard, there's a range here. If you have a range, it just does -1, but it's exclusive. So it's exclusive, but it starts at it. And this is an exclusive editor and an inclusive editor. We can create inclusive editors. We can do inclusive range, and that's actually going to be cleaner in this case. An incl range, rather than putting some on it, so 0 actually works fine right there. And we start from the bottom because we're going to remove something from this now. When we eat the food, we're going to do dots.remove index. We're going to remove that one from there. And then we're going to add another one to it, and that should be fine. Oh, we have to actually do this. This is really silly. And eaten dot. Obviously, that makes sense. What equal GD food 1. This is food 0. So these just aren't random things. They have specific things, but I'm just trying to keep it generic to show how you'd add more eaten dot. Then what do? Score +2 body length, same for that, and we have to remove it as well. Dots.remove index. What equals GD monster. And we're on the same position. This is why we have different comparison. If we're on the same position, then we say a lie equals false. There's nothing else we actually have to do here. And wait, we have bushes though. Where are my bushes done? Check collision. Alright, so we have this in collision here. We have the find bushes here. And we're actually going to change this. We can get rid of that now because we already have a way for that to do it. So we can get rid of the bushes collide here and put it back up with our monster here. Dot equals what monster, or what equals GD bush. There we go. I think that should be fine. And now, the other lot says, what we haven't done yet is we have to change the game render as well. That it's been working with fixed dots, so it has these dots here. So instead of doing this, we're going to go through all of the dots instead. And you saw in the other one, we have these types of index things. Let me go to the standard library for vector. Oh no, that's actually wrong. That's not. This is. There's an X collections vector, and it's called X collections because I'm being very honest here that there's no way this is surviving as is to the final standard library. But it has a for each function that passes the value into a function there. It should use referencing of some kind, but I just don't care. So I'm just going to do for each. And you can see then how the in Leaf we can look at how lambdas and closures actually work. Dots.for each. And now we create a function. We don't even have to know what type it is. We're just going to do this. This is a function. Because the other side is strongly typed, it's going to take this, which is weakly typed, and it's actually a parametric, and it's going to instantiate it based on the target function, and then call it. Alright, and then based on what, we're going to have something funny here. We want to have... Okay, what are we pushing here? It's 1, 1, 1, 1, 1, partial time 1. Alright, so we have a special case for bush because it has a different partial time. But we have the different values at the end. This is the sprite lookup, where in the sprite lookup this is. Now, because we have an enum on the other side, we could actually make this lookup directly into an array. And let's try that. Oh no, let's not try that, because I don't have an easy way to do standard arrays yet. So let's just do it simply. Let's do var sprite equals. I'm going to do a select now, and this is unfortunate. We do x.what equals gd food 0. Becomes 3, 1, and this is really mean about adding matching eventually, like Rust style. To do something cleaner here, monster, 4. Otherwise, we're just going to say 2, 4. Everything else is a bush because hey, you know what? If it's a clear idea something's wrong, or maybe we should make it something else that we're not expecting, so we very clearly see something wrong with it, and I don't know, whatever. We'll just make it a bush for now. We don't make errors, do we? But now we have a special case. If we do have a bush, then we do something different than if we don't have a bush. If we don't have a bush, we're pushing the dot state, and we're taking the... We actually call this x. This was the color, and the reason why the color is always 1 is because we have a sprite map. We're not altering the color. Partial time, and then the sprite. Otherwise, we push the dot with a 1 partial time. We could make an argument that maybe we should just make an if statement for the 1 parameter, but I'm just going to do this for now. Alright, and that covers all of the dots. We're going to find out. See what kind of wacky errors my compiler emits. Alright, that's a reasonable one. It's just an error. 246. Oh yeah, because I have a function here. So this has to close that off. Invalid type syntax in game 26. Forgot the comma. Again, commas here are also something that's on my list to get rid of because we don't have semicolons elsewhere, so why not just get rid of commas here as well? That makes perfect sense, and I'm going to add that. They will always be optional though, so don't worry. You can still stick them in. You can still pack together onto one line if you really want. On an operator, this makes sense as well. I am not overloading these operators because they're really hard to look up, and there's logically no reason why double pipe means or. Or is just as short, it's cleaner, and it's easier to look up any keyword thing. Now, game 224, I still have an error here. I always forget then. Alright, Bush game 71, that's fine. Bus.what, that's fine. And index not supported on 196, yeah. Alright, this is an issue because I don't support overloading of the indexing yet. That's just say yet. We just do yet for everything, and not in the render of the game itself. With the step check, step dots. There must be a step dot as well. We screwed that up. Right here, we can't do it here either. So step dot set index, comma dot dot dots dot get index. There we go. Or not. Monster's missing. Oh, that's nice. Where's our monster? Ah, there it is. Dot dot position. Uh-oh. That's bad. What have we done wrong? No, segmentation fault. Leaf is a safe language. Can you trust me on this? Or it's on my list. I do not have the safety checks on arrays yet. So the most likely thing that caused this error is something to do with those arrays. What I'm going to do for a moment is I'm going to do exe/temp/wormies. We're going to generate the actual exe, because then we can do a GDB on Wormies. We can actually debug this thing. The function names aren't perfect, but they will work. And alright. There it is, there's Sigma. Alright, and so this is where it's really weird, is that because I think I'm looking at the console, nothing happens, but it's actually segfaulted behind it. So you see an actual segfault, and we can look back where this is. Now, admittedly, the names kind of, they suck ass right now, right? This is a terrible naming. And this is a real problem in Leaf. What I focus on right now is guaranteeing the names are correct cross modules, because when you link a whole bunch of stuff together in modules and classes and everything, the names have to be unique for the linker. And you have to have references, and they have these little bits in front of them just for referencing, but we can see it. We have this push rect here. And the fact that push rect segfaults is really weird. But it's definitely in push dot. Push dot is an issue. And a push box and push rect. I don't have a line number yet. This is what's really missing right now, but I have the function. So let's go look at the function and figure out what could have done it. We do push box. Push rect. This is highly unlikely that push rect actually caused a segfault. What's more than likely that happened is that we have too much memory used. Does anybody know how to check the memory used by a program that's currently in currently being debugged? Let's check memory. Because that's my fear, is that it's using too much memory. But it's not. It's not even in there, is it? Grep demo. Oh, Wormies I actually called it, so let's do Wormies. It's still running. I don't know how to check the amount of memory it's using. It should be in top, because it's using a lot of it. If I sort by memory, you'd think you see Wormies there, because that's my only guess as to what's actually happening with this memory. Alright, let's find out what push dot is doing. Could push dot actually do something else? Well, I'll be damned there. Is there something wrong with my state passing here, my closure? Let me not push any dots first of all. This is going to be a bit difficult to debug. Alright, I didn't want to do that. I want to run the thing. Well, yeah, this is fine. I think I hit something most likely, right? Because nothing's being drawn. I fear the closure isn't working. I have touched those in a long time. So let's just do this. Let's just do a print here. Standard.println. Let's do it. X.what. Let's see how many of these actually run. Maybe it's one, maybe it's none, maybe it's nothing. .1, alright, wonderful. We've got the first dot crashes, which really scares me that we've really screwed something up then. And I have a really good idea what it is with the closures. I think we've encountered a defect with the closures is that this push dot here, I think it's being bound wrong. And so this is, I'm going to debug this offline. We have an alternate way to do this, and we're just going to go with the alternate way, okay? We're just going to do the loop wave for D and standard range 0, comma, state dot dots dot get size. Or dot equals state dot dots dot get D. And we called it X, so let's just go for X. Now if this fixes it, then it's very clear what the problem is. And that fixes it. And why are those things also so big? Why are the bushes the right size and everything else so big? Let's start. Alright, so the crap's not moving either, which is they're really big. And big is cool, but you can't see where they are. So we have a few issues here, but okay, this is a big to-do for me. This is a scary one. No, this on push dot is wrong. It's binding to the wrong context. And this might be a case that I'm going to consider is I'm doing a closure that's calling a member function from within a member function. Otherwise, closures tend to work. Closures are like a really hard thing to implement. They're not exactly fun, and I don't really want to touch that code again, but it looks like I have to. So we have these things, they're too big, partial time. But the partial time was 1 before anyways. That was correct before anyways, I thought. Oh, but right, because it has that scale in effect. So it's a game.leaf is the problem. We do step dot. Dots.set index is step dot dots.get index. Okay, step dot. Well, we should read this. Oh, that's because I screwed up the warm-up. Yeah, I forgot about that. Let's get rid of that first. Let's just ignore the warm-up first of all. That's we were halfway in the middle of that feature. Now they move at least. We can make giant monsters. We're going to ignore the giant monsters though. And we're going to quit there and figure out. Now this is still fine. They shouldn't move. Where's the step warm-up there? Step warm-up. We actually have to do the stepping of the warm-up now. And we're going to do the same thing here. Var dot equals dots.get index dot warm-up dot warm-up minus equals. I think this has to take the elapsed value as well. And then we're going to set it back to the dot. Now there's no good way to get references out of the vectors yet, because there's cleaner ways to do this, and so this is more, I don't know, it's a form I don't really want, but we are living with it for now. 179. And again, I forgot the then. I don't know why I do that, to be honest. It's just like, I'm not used to the syntax of my own language yet. Right, so the other things are big. So I zoom in and then they zoom in. And you can see immediately what the problem with there was, is that everything should zoom in at the first time when it comes in at the same time. It shouldn't wait for just for me. It's a little bit distracting for the user, but that's how these types of games work. And oh, the things aren't colliding with each other now, so we still have an error in there. That's okay, we can live with that. So the the fruit and the monster should not run into the bushes, so we have to do a double check for the collision again. Alright, so let's let this die. And let's just see that start again. So I zoom in, and then they come in, and that's the bit of the problem there. We want them to come in at the same time, but more importantly, we want to fix the collision stuff first. And the warm-up time is way too long on these things. So let's do this a little bit differently. Game warm-up. Now this should probably have the same sort of... I'm just going to use warm-up max for now. Give them all the same time and it's consistent. But we don't really have a way to express it correctly yet. And what is it? The check collision does collide with the board. I made the mistake that does collide with the board, and I might have to get the... Just give me a sec to get the door to let in the screaming people. Just 1 second. Alright, so now I'm back, and I got light on. You know, it's a wonderful thing to have light. And today's a birthday. I'm supposed to be making whipped cream right now, but I don't feel like it because then I'm just going to sit out there and eat the cake as well. So I'm going to have to wait a bit. And if I get this working, this will be the last thing I do for the stream today. That'll be fine. I have to get the check collision. I just want to get these animations working. Does collide board is where we screwed up. This now has to go through the dots as well. We can go through the dots this way again as well, which really sucks. Now, does collide board becomes a real issue now? Alright, because this is only supposed to be bushes, so that's fine. Dot what does not equal GD bush, then we're just going to continue here. Now you don't actually have to put these, you can just say then continue, it's a shorter form. And we do an equals on this, equals dot position, comma position, then return true. It does collide. Is that enough to watch them bounce around? Did I screw something up? Continue. Next. Why do I have syntax highlighting on something I don't support? Oh, that's fun. Oh my. Oh my, what have I done? No, 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 no. This game has suddenly become unbelievably hard. I'm going to play it for a bit before I fix it. Let's see if I can play this game. There's bushes everywhere, and they're moving on me, and they're probably just going to bounce around, who knows where. I move out of the way the flower, or the bush, or the fruit, and so now the game has gone crazy. And I haven't a good idea of what it is, because what we've done is all the bushes are now also checking for collision. And when something hits something else, which means the bush itself hits itself, it gets a new direction, and it never checks to see the fact if it was static before, it shouldn't get a new direction. It just moves it anyways, just in case, and that's mainly for this fruit. If it happens to randomly start on a bush, it'll move off that bush, which is a really good thing. And the bushes themselves, nothing else is checking for collision. The bush and stuff is not, just the... Damn it. Nothing else is checking for collision, only the bushes are. So that's clearly quite off. Where do we do check collision? We do does collide board. There must be somewhere too. Step dot does collide board. Alright, we're gonna recheck this. We gotta say yeah, dot what does not equal GD bush. So this is what I feared about when I combine these all into one big dot structure, that we have to worry about all these special cases. So the bushes don't move around. The thing is, did the apple actually take? Watch the apple and watch the monster. They actually hit us now, and that's what we want. They'll change direction. So I got that working. They don't scale correctly quite yet. You notice they don't scale correctly on their position, but we have them zooming in a little bit at least, and we have sanity restored. And it's not so bad if those things zoom in the wrong location, but let's give it a little bit of love and try to figure out how to fix that. They're also a bit slow. They don't have the right animation that we do, because remember, our animation is a little bit faster. And it's not so bad, though. It's not so bad. And they're right there. If you saw, I didn't actually hit the cat. He ran into me, but he did not hurt me, because he hit my head and he decided, hey, I should change direction instead. So there has to be a special exception for the cat, that if he's going to run into the head, it's totally okay, rather than us just running into him, because otherwise it makes it too easy. But let's worry about the animation first of all. I want zooming to be correct in the field renderer. So the field renderer, where are we doing that? We're doing the draw dot, we're doing a push dot, or push dot. Alright, and push dot pushes a box, and a box takes the top left position. And the size is from there, which isn't necessarily what we want. We want the position to be in the middle of the thing. So who calls as push rect? Render background. Alright, so render background is kind of part of the issue there, that it uses the full rect. So push rect makes the most sense. But what we're going to do here is do minus size divided by 2. And we're going to add the 0.5 here, so it's going to start in the middle. So we're going to do the centering here, and this should hopefully make them zoom in right in the width. So let's start. Yeah, that they zoom in correctly. Whoa! No! Oh, that worked actually correctly. Watch the cherries and stuff. Do they go in the right place? They do. I don't know what happened on the front one. Why'd I die there? That's weird. I think we're off by 1. You notice up here? We're off by 1. And why are we off by 1? We're in the wrong direction. So I totally screwed something up. If I add 0.5, then I minus the size divided by 2. If the scale is a half, that should have given us the same value. except I think we're inverted. Why the hell did I put a minus? Oh, I put a minus here. That's weird. I think that was just a mistake there. Let's check that out. Yeah, okay, that looked better. Oh man, stupid menus. Who designed these menus? They don't know anything about UX. Come on, people. Alright, so now they zoom in, and that starts to look better. We can add more effects later, but we have the basic effect, and I wanted to show how you introduce such effects into like the game engine itself. And now I should be able to go right through here. Yeah, we have the things in the right place. So I have the worm going, and let's do a few patches to the game itself now. When the worm hits our head, well, let's do a check in here, get status. Get commits, scale in of opponents, or of stuff, let's say stuff. Oh, sorry, get push. And now let's fix the game up so that if the cat-like creature actually runs into us, he doesn't die. And this is where the monster is. Monster, monster, monster. Alright, but this is now check collision. And we probably could do that in the same loop. No, step dot doesn't. Step dot. Step check, step dot. Alright, so does collide board end position, and this is what we have to watch here, is that does collide board. If this is a monster, does collide board. Excludes the head. And that's exactly, we already had that, and we were calling it before. And we have to do it here, does collide board, dot dot what, equals GD monster, and it excludes the head, I think, and so that he can run into us. Now this is very hard to check without an automated test library, which we should also do, but again, you would need the library to do that. We have to get in a position where the cat would run into us. Like right there, but I might have run into him, so let's figure that out. It's just going to be hard to get the timing right. Man. Can we just assume it works? I'm going to try a few more times, but this is like so hard to get the timing right. Get back here, cat. This thing's actually labeled bear in the Cpp thing, and then in the file we found it, it's labeled a bear. There we go. That's actually one. Now that little jump at the end, that's another animation we have to fix, is because when the game's over, there's no more partial time in between frames. It just sort of ends, and then they all jump to the maximum time. And alright, but that's good enough. We fixed him, so get status. Let's do that. Get commit. Monster can run into our head. Now the one thing I want to do more is actually introduce another gameplay element. Anytime we eat one of the candies or the cherries, maybe cherries, let's add... Well, let's add another fruit type. So let's go over to Inkscape again, and I had this thing before. This is all the stuff I do for this show. You're probably off the screen right now, so just let me put you back up onto the screen. I don't know, can I move this to all desktops? Keep you on the screen. Was it one of the recent ones? We have the foreground sprites. Whatever, just be happy with that. Right, so let's add another fruit. Let's add one that adds bushes when you eat it. Gives you more points, but adds a bush. I think those are really good. It adds a few bushes. And which one should we choose here? Anybody have any preference for which one we choose? Maybe we should choose the peach bum, or the double peach bum, or a pear, or a strawberry. What do we have now? I really forgot what we have now. What do we have now? We have a cherry and an apple. So, what do we want to use? If nobody has any preference, I am going to go with grapes. Purple grapes, because we don't have purple grapes. So this is cell 3, 0. 3, 0 is the purple grapes. Now let's go put that up. Literal GD food 2 equals 3 is 4. And set next. Bush fruit. I just call it bush fruit. Now I really should have called these something else, but the thing is that the renderer doesn't care. We care, but the renderer doesn't care, so you might want to have 2 literals for the same thing. I'm going to cleverly ignore that for now. Set next, eat me, set next, chase me. And it's going to be static, like the eat me one. Set next, bush fruit. Next dot is it's a dot food 2. And its food direction is it doesn't move. And it's going to add it. Then just check is when we eat this thing, what happens to it. I have to do another condition here. GD food 2 and eaten dot. Score, let's give it a score plus 3. And I don't know how much this should increase the body length. Why don't we just leave it at 2, but we're going to add bushes as well. Set next, bush fruit. And now we have to come back here. We add a bush somewhere, right? We have add bush. How many bushes should it add? Just one's not going to be very many. It's not like a huge punishment, but let's deal with it for now. Let's pretend it is a bush. And this is the case here that maybe in this case, bushes should actually have the warm-up period as well so that you can see them come in, where they're coming. But that might also distract the user, and I'm really concerned about, let's just try it this way first, add bush. But see, adding new things is a lot easier, as the game renderer is not going to be so hard. GE food 0 is all we really have to do is stick a new food type in here. And we said this was 0, or 3, 0. And that were the grapes we wanted to use. Right, so now there's grapes on there too. Perfect. And we ate them. And you saw a bush appear. And they're gonna. This is their best way to get points, though, right? This is the best thing to get points, but it makes the game harder and harder to get more points that way. And we're not really worried about balancing too much right now. It's just sort of a concept to show how you can balance things. Is we have these grapes, and we're going to eat these grapes, and they keep adding bushes. And that one grape was moving because it must have started on a bush. We don't exclude bushes from where things start, but if things start in them, even if they're static, they will move around. And so it doesn't take very long for us to get longer, and these bushes already are piling up enough that one bush might be a cost enough for the grape. Alright, so let's commit this here, get status, get commit, add bush fruit. But that was a good example there, and I'm very happy with this, how quickly and easy it was to add a simple concept like that to test something. So I'm going to finish the stream now on this note here. Let's play around in this game. Let's see what happens. I'm going to make it as big as I can so everybody can see it. And I'm going to start playing, and I'm just going to deal with it. So, alright, that was really unimpressive. I'm really sorry for that. I died immediately. And that's because of the thing we moved in the opposite direction. Oh, let's fix that first. Let's fix that first, okay? That's really annoying if you do a move. And this is a special case. X off equals... where's our direction? Direction.x. And if it's the opposite... now, you both of these can't be 0. So it really only has to be the opposite of 1. And so that's really weird, because 0 is 0 is going to be 0, 0. That's going to be fine. And then what we're going to do in this case is we're just going to return. We're going to be totally fine with this. No, it can be applied. It's not. I'm playing it in the wrong place. Move is still fine. What do I call step requests? Where's our request thing? Request dir. Dir right here is right here. Request dir equals dir. And so we're going to say var next dir, and we're going to check it right here. If next dir, and we're going to do the inverse condition. If next dir dot x does not equal the negative x, and next dir dot y does not equal the negative of dir dot y, then dir equals next dir. This should prevent us from like walking over ourselves by accidentally pressing backwards. And this does happen because you get excited, and it's not really a fair thing to do the game that way. So if I press right, I can press left now and it doesn't hurt me. And that was the idea. So I press up and it doesn't hurt me, left. And that also helps in situations where you have to like reverse your direction, that you don't accidentally press the keys in the wrong order. If you do, it's not tragic. Just one of them won't do anything, which is better than dying. It's still a punishment. You're probably going to end up in the wrong place, but you won't die. So let's start this thing over again. Big thing, return to game and start. We have grapes. So let's talk about what we did in this game. What we did in this episode is we converted all of the things we eat into a common dot structure. When the things come on the screen, we made them phase in like that. The worm also has a special way where he phases in, and we saw it right at the start. And I won't be able to show it again without dying, so I can try and play it for a while. We fixed the situation, a very minor one, where the cat wouldn't run into our head, and now he does. And the grapes now are a special thing, that when you eat a grape, another bush appears on the board. You get more points for it, but a bush appears. Whether you want that or not is up to you. It's just an example of another feedback mechanism in the game, another consequential thing, and I don't know why I died there. It's hard to talk and play at the same time. Let's do one last look at the zooming in. When I start, you can watch the players zoom in, and that tells you where it is to start, so you have visual indication. A lot better than before. And it automatically starts. You don't have to press a key. If you press a key while it's starting, it will just take that direction initially. Now we can press back as well, so you don't accidentally walk in yourself. So now the controls are feeling a bit more reasonable. We also added the WASD keys, for those people that prefer those, for your PC gamers out there that are right-handed and use a mouse on the right hand for your FPS and WSDF for anything else. And we also added enter to the menus. So we return to main and we start, and we're going to end the show this way. So we added several small things. I'm not sure what we'll do next. Maybe next time is, and you guys can always give feedback, whether next time is perhaps, alright, wow, we started on a bush, that's interesting, we didn't die. Next time might be a good time for us to add a computer opponent, or maybe a second player. That might actually make more sense. Let's add a second player, and then we can add a second menu to the game items. So we have 3 menus. We say start new game. And then you can start like a new game with 2 players, how many players you'd like to start. And then we'll have 2 players, and that's actually a fairly significant increase to the game, having 2 players. And that's going to be, so let's do that. Let's add a second player, because everything we need for that will be required for the AI player as well. But it lets us set it up without having to worry about the AI at the same time. And I think that'll be a good way to do the next show. But let me know if you have any feedback about that. At some point we're going to have to add sound, add gamepads and stuff like that. Still lots to do, but I think we've come a long way, and I'm very happy with this. Again, feel free to ask. And please follow me on Twitch and on Twitter to find out about the shows. I'm going to try to create a regular schedule to the show. I can't promise, but it's going to be like probably just 3 times a week. And I might start a new graphics show about just doing graphics from the ground up instead of already. I know it looks simple, but we're already fairly complicated in terms of some of the graphics. And we're going to start from the ground up, and I'm going to figure out a project name of drawing triangles from the ground up using GL and what it means and how to do graphics. And we'll eventually get into how to draw lines and stuff. And so please follow me. For right now is the best time. I will update the time schedule as soon as I know. It's probably going to be something like Wednesday night and Friday night for this show, but maybe Thursday night instead. And then maybe Sunday afternoon. That's going to be less sketchy. And the actual graphic show is going to be during the day, though, like at 10. I know a lot of you won't be able to see that depending on your time zone, but if you're at work in Europe, you can watch it on the side and enjoy it. And if you're in the US, you can always watch it on YouTube afterwards. So I thank you very much for watching the stream, and I hope you have a good day or evening. Thank you.